Hi everyone, today our group will present our project for the electromagnetic field and waves course titled Investigating the Effect of Static Electronic Field on a Candle Flame. Here's our team members, Lijunhan, who lead the experiment planning, and myself, LIUXUEHAI, responsible for the video documentation. So let's begin with our objective. We aim to investigate how static electronic fields affect the shape and movement of a candle flame. This is possible because the flame contains ionized particles, ions and free electrons produced during combustion. The key idea is simple. Electronic fields apply force on charged particles, and since the flame contains these particles, it should be visibly respond. So this experiment is visually engaging, contains testable theory to real-world phenomena, and directly reflects on the principle of electromagnetism. Here's a summary of the physical behind it. The electric field E is defined as voltage divided by distance, and according to Coulomb's law, a particle with the charge Q in an electric field E experiences a force F equals to EQ. The direction of the force depends on the charge's polarity. In a candle flame, combustion produces positive ions, electrons, and neutral particles, making the flame potentially conductive. So when placed between charged plates, the flame should react due to this force acting on its charged particles. To test this, we use 5 main components. The first is a candle for the visible ionized flame. The second one is 2 metal mesh plates, act as the electrode to create the electric field. And the third one is high voltage DC source, generating the static electric field. The fourth is a wooden base to hold everything safely and insulate the current. And the last one is copper wire, connecting the plate to the voltage source. So this setup is simple. The candle is placed between the 2 plates, which are connected to the power source. This creates a static electric field across the flame. By adjusting the plate distance, we can control the strength of the field. A closer distance means a stronger electric field, which may cause a stronger flame deflection. Here you can see our real experiment setup. The candle stands upright between the 2 metal mesh plates. These plates are connected to copper wire to the high voltage power supply. This design allows us to safely observe the flame response under different field conduction. The mesh structure ensures the field is even distributed, and the open design helps us clearly see the flame behavior. Overall, this is a simple but effective setup to demonstrate how a static electric field affects an ionized flame. We test different distance between the plates. First, at the medium distance, around 10 centimeters, the electric field was moderate. The flame started to flicker and slightly bend to one side. And then we tried another short distance around 4 centimeters. The electric field becomes stronger, which makes the flame flicker violently and currently bend, showing the strong response. This confirms that the distance between plates decreases, the electric field increases, and the flame movement becomes more obviously. These observations support our theory. The flame contains charged particles, and they respond to the electric field. This experiment results match our theoretical expectations. According to the F equals to QE and E equals to V over D, the stronger the electric field, the greater the force on the charged particles in the flame. This visible flicking and bending of the flame indicate the positive and negative ions are being pushed in opposite directions. We also observe something called ionic wind, a movement of air caused by the ion flow, which may contribute to the flickering. However, there are some limitations. Natural airflow in the room might affect the result, and the exact field strength was not measured, and humidity can reduce the effectiveness of static charge. And in the future experiment, we can use better things such as the first, a wind-proof box, the second one, a more stable voltage source, and the last one, a way to measure the accurate electric field. To conclude, this experiment clearly demonstrates how a static electronic field can affect a candle flame. The flame behavior is flickering and bending, shows the presence of ionized particle inside the flame. This experiment successfully contains theoretical knowledge with real-world observation. It helps us visualize Coulomb's laws and understand how electric field influence matter. In short, it was a simple, safe, and powerful demonstration of electromagnetic principle in action. Thank you very much for your time and attention.